Welcome to a video lecture. So today we are going to see about the testers for bitumen. So first of all we see about the penetration test. In the figure you can see the penetrometer which is being used for testing the bitumen. So the penetration test determines the hardness or the softness of the bitumen by measuring the depth of a millimeter to which the standard loaded needle will penetrate vertically in 5 seconds. The sample is maintained at a temperature of 25 degrees Celsius for 1 hour. The dial is set at 0 or the initial reading is taken and the needle is released for 5 seconds. The final reading is taken on a dial gauge. After each test, the needle is designed and wiped with benzene and dried. The depth of the penetration is repeated in 1/10th millimeter units. The value is influenced by any inaccuracy as regards pouring temperature, size of needle, weight placed on the needle, and the test temperature. The bitumen grade is specified in terms of penetration value. The penetration test is applied almost exclusively to the bitumen as road tars are soft. The penetration test can be carried out on these materials. The penetration values of various types of bitumen used in pavement construction in this country ranges between 20 and 22 by 54, 30 by 40 and 80 by 100 grade bitumen and are commonly used depending on the construction type and climatic condition. So the next test is the ductility test. The bitumen paving engineer would however want that both the test requirements are satisfied in the field jobs. It is expressed as a distance in centimeters to which the standard briquette bitumen can be stretched before the thread breaks. The test is conducted at 27 degrees Celsius and at a rate of pull of 50 mm per minute. The ductility of machine functions as a constant temperature water bath with a pulling device at a pre-calibrated rate. The ductility values of bitumen vary from 5 to over 100 for different bitumen grades. In the flexible pavement construction, where the bitumen binders are used, it is important that the binder form ductile thin films around the aggregate. This serves as a satisfactory binder in improving the physical interlocking of the aggregate bitumen mixes. Under the traffic loads, the bitumen pavement layer is subjected to repeated deformation and recoveries. It is carried out on bitumen to test this property of the binder. The test is believed to measure the adhesive property of a bitumen and its ability to stretch. So here you can see the ductility test from where it has been started and the end point before the break of the thread. And in the second picture which shows a standard briquette mount. So that is an apparatus which has been used for finding the ductility value. So the minimum ductility value of a 75 centimeter has been specified by BIS. So you can see the formation of a thread, how much it has been stretched. So the next test is the softening point test, or simply we call it as ring and ball test. The softening point denotes the temperature at which the bitumen attains a particular degree of softening under the specification of the test. The test is conducted by using ring and ball apparatus. The sample should be just sufficient to fill the ring. The excess sample should be cut off by the knife. Heat the material between 75 and 100 degrees Celsius. Stir it to remove air bubbles and water and filter it through the ISC 30 if necessary. A brass ring containing test sample of the bitumen is suspended in the liquid like water or glycerin at a given temperature. Remove the excess material with the help of a warmed or sharp knife. Assemble the apparatus with the rings, thermometer and ball guides in the position. A steel ball is placed upon the bitumen sample and the liquid medium is heated at a rate of 5 degrees per minute. Fill the beaker with the boiled distilled water at a temperature 5 plus or minus 0.5 degrees Celsius per minute. With the help of a stirrer, stir the liquid and apply the heat to the beaker at a temperature of 5 plus or minus 0.5 degrees Celsius per minute. Apply heat until the material softens and allows the ball to pass through the ring. Record the temperature at which the ball touches the bottom, which is nothing but the softening point of that material. Generally, the higher softening point indicates that lower temperatures susceptibility and is preferred in hot climates. The next figure shows which softening point test setup. So I can see the softening point tester. I can see the ring and ball and how a starting point in that experiment and how it end point you can see. So this is the end point, the figure which shows the end point of the softening point test. So the next comes the viscosity test. So the viscosity denotes the fluid property of a bituminous material, and it is a measure of resistance to flow. At the application temperature, this characteristic greatly influence the strength of resulting paving mixes. Low or high viscosity during the compaction or mixing has been observed to result in the lower stability values. At high viscosity, it resists the compactive effort and thereby resulting mix is heterogeneous. Hence, low stability values, and at low viscosity, instead of providing an uniform 1 meter over aggregate, it will lubricate the aggregate particles. Orifice type viscometers are used indirectly to find the viscosity of the liquid binders like cutbacks and emulsions. The viscosity expressed in seconds is the time taken by the 50 milliliter bitumen material to pass through the orifice of a cup under standard test condition and specified temperature. Viscosity of a cutback can be measured with either 4 mm orifice at 25 degrees Celsius or 10 mm orifice at 25 or 40 degrees Celsius. So here you can see the bitumen sample which has been tested for the viscosity test. Thank you.